Welcome. We're in the Stockton Delta in beautiful California, and we're spending some time with Andrew Petrini. He's got some recently acquired land here that he's putting some trees on. So Andrew, tell us a little bit about what you got going on your piece of the world here.
Sure. So in 2018, we planted about 200 acres of olives on the super high density system for olive oil. And then this year we planted another 120 or so acres of olives in the same system for olive oil and 125 acres of almonds.
Wow. Are you getting good at planting?
Oh man, it was pretty stressful there. We planted this year, so we put in about 245 acres this year, and in 6 days we had 245 acres of trees planted. So it was a wild 6 days.
You're still standing upright,
yep.
So the limp has gone away.
Yeah.
On your first planted olive trees, you know, and that's always the big expense, the big undergoing of getting everything planted. How did your first planting go on the olives?
We had one variety that is a little bit more temperamental when it's planted in tougher ground that we're on. So we had to baby it a little bit more. It was a little bit more challenging, but it's pulling out of some of its issues, and it's going to be a fine orchard. Okay.
Do you have nice uniformity and nice balance and symmetry of the vegetation that is growing?
Yes.
Perfect.
Yes.
Perfect.
Like a straight line.
When was this almond tree planted?
What's the date today? So the 25th?
6th?
Yeah, it was planted on the 21st.
Okay.
October 21st.
Depending on the variety, depending on a lot of different things, what I like to look at is what is the average of the leaf size that this tree came from the nursery. Because see, those nursery guys, they're sharp. They want to get those trees up and going. So when you see leaves, a leaf potential like this, that tree is saying, okay, give us a good environment, this is what we can do.
Right.
The environment that this tree got started in is probably a little bit more polite than what it is right here.
Yeah.
So the one thing that you want to look for is any subsequent leaves coming out. If the nutrition, if the microbes, and if everything are balanced, you will continue to get nice big monster leaves, because these are your solar collectors for your carbon sequestration.
Sure. Yep.
The quicker you can fix
the entire area,
everything.
Because I don't want the roots to stay there. I want them over here as well. So
and over there,
everywhere,
and over there.
Yeah.
Yeah, and most guys are just focused on the berm, and that's great up front. Just like we talked about before, is once that's fixed, that's perfect, but it's not enough.
Yep.
If you want longevity in your trees, if you want healthy stock, if you want good yields and minimal inputs, you want roots everywhere.
Yep.
Like we said, the quick, and you may giggle at this, but the quick, easy part is tying up and getting rid of the salt and the sodium and the magnesium. That's the easy part. It's getting the microbes to exist. That takes time.
Yeah.
So the dormant calcium will take care of the salt, it'll take care of the sodium, it'll relax the magnesium. Then you can start getting microbes working for a month, 6 months, a year, and they're going to prepare the soil for those roots to be coming. And the more time you can have to prepare that, for the microbes to prepare that soil, the more inviting that soil is going to be for that little root.
No, that is the right thing to do. So
this ground that you get to call yours, is it the Garden of Eden? Is it the perfect soil, or is it?
It's hell.
Okay. Now, when you say hell, what does that actually mean?
It's just been neglected for a lot of years.
Okay.
Zero inputs. Farmed. Just really wasn't farmed. It was attempted to be farmed, I guess.
If it was a horse, it would have been whipped hard and put up wet?
Yeah, it probably would have just died. It's but the ground has very good potential. This is good ground. It's just been neglected for a little while.
Okay.
So,
What are the biggest things that you see potentially giving you a problem with this ground?
salt or sodium,
Okay.
and it's deficient in every nutrient there is. And that's where it got back to zero inputs. It was just the ground was mined. It was mined.
Any magnesium problems?
Yep.
Okay. With the salt, with the sodium, with the magnesium, what's your plan of attack that you think, or that you, have you seen anybody else fix high salt, high sodium, high mag ground that you've got some hope, or are you just throwing it out there and singing a song and a prayer?
No, I've been watching someone who's been doing the same thing that I'm trying to do. I'm following what he's doing, and I'd say he's mentoring me in what to do right, and it works. The proof is in the pudding, and it works.
Okay. So is there a product or is there a piece of equipment? What will you do? What will you do to lower the salt, sodium, and relax the magnesium in the soil?
So we're going to spray GSR calcium, and we're going to put cover crops in to help keep the ground open. In the springtime, we'll work all that material back into the ground and just keep doing the same process until we achieve what we want to achieve.
The GSR calcium, how much calcium will it take to fix salt, sodium, magnesium issues in this? A ton, 2 ton, 5 ton? What will you use, and what have you seen work in the past?
Well, we use it in grams or pounds.
Oh, come on. A few pounds of calcium? What's that going to do?
I'll show you.
Okay.
I'll show you. Yeah, we've used it in the past just in grams running through sprinklers, and in the permanent crop setting now we're using it in pounds, but we're talking minimal pounds. So, and I don't know the correct number yet, but it hasn't been taking a lot to see changes. And by a lot, I mean like a pound, and you see significant changes.
Yeah. Well, and obviously we manufacture this calcium, and I was trying to be a little bit funny. You aren't the first person or the last to maybe be a little bit tentative to jump in, but I'm guessing the person that you're speaking of, Frank Oligary up north, you've seen what he has done.
Yes, I've seen what he's done, and we've farmed ground that he's currently farming, and I could tell you that it's not the ground that's making what he's doing work well. He's not on what I'd call primo ground. He's had to do work to the ground with these products, and these products are making the ground into good ground.
Yeah. So with this, you've got your trees planted. We're coming into, I guess, would you call it winter?
Yeah, fall.
Okay.
Well, it's supposed to be fall, but we don't know what fall is in California anymore.
Okay. First of November. And when you apply this calcium, what kind of weather are you looking for afterwards?
Some rain.
To
push the calcium into the ground and to try and start tying up materials and loosening up materials and get the anaerobic going in the soil.
Yep. Many farmers and growers don't realize that air is the most important input, that contains 78% nitrogen, that contains 20 to 21% oxygen, and every mineral that a plant wants has to be hooked to oxygen, and there's nowhere for that plant to get oxygen other than the atmospheric air being pushed in with a high pressure, heavy air system into the soil. So the whole goal, what we're trying to do is, A, we need to get this soil decompressed or uncompacted to open it up to get air in. So we get rid of the salt, we get rid of the sodium, we get rid of a lot of the electricity. Now you've been taking some EC readings, electrical conductivity readings. What are some of the bad readings that you're seeing on this soil?
3 is probably some of the worst.
A 3.0.
3.0, yeah.
Yeah. And you've seen in the past that most microbes will not survive over a 1 or a 1.2.
Correct.
So you're 3 times hotter than what most soil aerobic beneficial microbes appreciate.
Yeah.
Okay. You're confident that a few pounds of the dormant GSR calcium will reduce that number down and open up the soil and get some microbes in there?
Yes.
Cool. So once the salt and the sodium goes away, then you've got magnesium. Magnesium, which we've talked about in the past, magnesium is one of the electrolyte minerals that loves to grab onto nitrogen. Excess magnesium will tie up nitrogen on a 1-to-1 basis. You have some excess magnesium in this soil.
Yes.
In most cases, the higher the magnesium, the more nitrogen that's needed. Now you've got these fresh started trees, and what kind of a nitrogen program are you on with these trees?
Nothing right now other than...
Whoa.
Well,
You're telling me you've done no synthetic nitrogen on these babies?
other than compost. There's no synthetic N out here.
No calcium nitrate,
No.
no urea,
No.
no 28,
Nothing.
no 32,
Nothing.
no ammonium nitrate.
Nothing. No. Nothing.
Do your neighbors think you're nuts?
Oh, I'm sure they will. I'm sure they will.
How are the tissue tests that you've taken on these trees that have gotten no artificial synthetic nitrogen?
So in the olives that we have, because the almonds here were just planted, but the olives, we haven't done any synthetic N, and we have a 1-year-old planting, and the tissues on the N have been what the lab shows either sufficient or higher than sufficient in N. So if sufficient was like I think a 2.2, we were running like 2.5, 2.6.
So you're comfortable that you're not going to need nitrogen, at least in the very near future?
I mean, it's not showing right now. I mean, they are young trees, but they aren't showing that they need it. And I've seen it where on larger trees that hasn't done it, put any synthetic N out, and tissues are fine.
Where's the nitrogen coming from?
Oh man, it's got to be coming from the air, right?
Think it's just coincidence?
No, I don't think so.
Well, and that's the fun thing that you've gotten to see at Frank's, is once the ground is opened up, the air that is 78% nitrogen can get into the soil along with 21% oxygen, and that's the carbon cycle.
Yep.
And as that air goes in, there's many other nutrients in there, and as you deepen that aerobic zone, you will start sequestering more carbon in that carbon cycle, and you'll get to sell it in the form of olives or in the form of almonds.
Yep.
So with this, by lowering the salt and the sodium, and some of your toughest ground is at a 3.0, 3 times higher than what microbes can tolerate. These trees like to be at a 0.3, a 0.4, even a 0.5. So you're almost 6 times higher than what they will appreciate. You have confidence that a few pounds of the GSR calcium will lower those numbers?
Yeah, oh yeah.
Okay.
Yep.
Reduce the magnesium so that the magnesium doesn't grab onto the nitrogen, so your numbers stay good?
No doubt.
Cool.
We wouldn't plant here if we didn't have the calcium to use.
Wait, say that again?
We wouldn't plant on this ground if we didn't have that calcium to use. So this ground would stay lower valued crops.
So knowing what the calcium would do is what made the decision that's like, we can make this work.
Yeah.
Andrew, you've got some volunteer plants growing here. What did you do before the trees were planted to prepare this soil for the planting of the almonds?
We leveled the ground so we would get adequate winter drainage, and then we spread compost, and then we ripped the ground. And one of the 3 ripping passes, we were injecting GSR calcium into the ground at different levels, and then we just planed it out and wormed it up and stuck the tree in the ground.
Have you noticed any change in the soil and what it grows in the short period of time that you've had this soil?
In the olive block that we planted in 2018, that was it was organic for probably 8 years prior to us acquiring it, and we did the same program, just ripped the ground, injected in GSR calcium, and the volunteer cover crop that we got, which was like a lot of rye, because it was pasture ground, it grew probably 3 feet tall, and there wasn't any, other than the compost, there wasn't any fertilizer added to it. Actually, the volunteer cover crop that had no synthetic N added to it was greener than the field that we're standing in, which was planted in triticale, and it was fertilized with urea. Greener.
How can that be?
Yeah, I don't know. You tell me, Professor.
Well, and it's fun because we talk about stuff like this, but when you give to Mother Nature in a natural, a healthy manner, she will say thank you back.
Yeah.
So by opening up that soil, by getting rid of the magnesium, by lowering the salts and the sodium, by allowing the microbes to have a little lunch of calcium, because the microbes have to have calcium for their physiological structure, Mother Nature said, hey, Andrew, thanks, man. Here's some really great grass that will help you turn this soil around quicker.
Yeah, and that's, I mean, it's there. I can't explain any other explanation other than opening the ground up and putting calcium in the ground, because we didn't do anything else. I mean, it grew. It really was amazing.
So if someone's watching this and they've got hard compacted soil like this, it still has a bad personality, doesn't it?
Yes. It still needs work.
You're not done disciplining this soil yet.
We're just getting going.
Okay.
Yeah.
But you spanked it a couple times already.
That is correct.
Okay. If someone watching has some compacted, hard, lumpy, clumpy, cloddy, cracked ground, do you believe the GSR calcium would help them open that up and improve their crop?
No doubt.
Perfect.
I've seen it.
Perfect. And seeing
is believing. Yeah, the proof is in the pudding, as I like to say, and I've seen it.
The only way that would have been better is if you would have went right up to the camera and said, like, the proof is in the pudding.
You listen to me.